At this point in our study of trigonometry, we are familiar with angles in degree and radian measure. Now it's time to define the 6 trigonometric functions. We begin in section 1.4.1 with the ratio definition of trigonometric functions. We're going to look at several perspectives of the trig functions, and our focus here, of course, is the ratio definition. 6 basic functions characterize trigonometry. In their full spellings, they are sine, cosine, tangent, cosecant, secant, and cotangent. To define these functions, we will use an angle in standard position and a point xy on the terminal side of that angle. Here's the official definition. If xy is any point other than the origin on the terminal side of an angle alpha in standard position, and r equals the square root of x squared plus y squared. So pausing right there for just a minute, on our diagram here, we can see that the horizontal segment of this right triangle is given by the x-coordinate. The vertical segment is given by the y-coordinate. Applying Pythagorean theorem, we can see that r is equal to the square root of x squared plus y squared. So r is simply the distance from the origin out to the point on that terminal side. Here's how we define the 6 trigonometric functions. Sine of alpha, we pronounce it sine of alpha, it's abbreviated sin. Sine of alpha is equal to the y-coordinate divided by r, whereas cosine of alpha is equal to the x-coordinate divided by r. Tangent of alpha is equal to y divided by x. Now, r is always positive. It's calculated as a distance. So the sign, S-I-G-N, of sine, cosine, and tangent is determined by the sign of x and y in each respective quadrant. Now, continuing, cosecant of alpha is equal to r divided by y. Secant of alpha is equal to r divided by x. And cotangent of alpha is equal to x divided by y. These 6 definitions are essential formulas for you to know. But notice they kind of come in 2-for-1 pairs. If you can memorize these in the first column, then there's a special relationship that they have with the formulas in the second column. What relationship do you notice? Hopefully you can see that sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So they have a reciprocal relationship. Therefore, if I know that sine of alpha equals y over r, and I know that cosecant is the reciprocal of sine, then I could determine that cosecant is r divided by y. We're going to be studying all kinds of interdependent relationships just like that throughout the semester. The more that you can recognize relationships like that in trigonometry, the deeper your understanding will become. This leads us to what we call reciprocal identities. Now, an identity is an equation that is always true for which both sides are defined. So our first one here, cosecant of alpha is the reciprocal of sine. And again, we can see that in the definitions. R over y is the reciprocal of y over r. Similarly, secant of alpha is the reciprocal of cosine of alpha because secant of alpha is r over x, whereas cosine of alpha is x over r. And finally, cotangent of alpha is equal to 1 over tangent of alpha because x over y and y over x are reciprocals. So take some time to memorize the 6 trigonometric functions and their ratio definitions and those 3 reciprocal identities. Now remember, this is in addition to knowing all the common angles on the unit circle in both degrees and radians and the formulas associated with linear and angular velocity. If you haven't noticed by now, trigonometry requires a lot of memorization. Let's go ahead and apply these definitions in example 1. Find the values of the 6 trigonometric functions of the angle alpha in standard position whose terminal side passes through the point -1, 2. We can begin with a sketch of the angle that contains -1, 2 on its terminal side. So plotting the point -1, 2, we can see that it's a quadrant 2 point. So the angle that contains that point would have its terminal side in quadrant 2. So we define angle alpha to represent this angle. Sine of alpha is equal to y divided by r. Now, we can see that our y coordinate is 2, but to calculate r, we need to know this distance here from the origin out to this point. So once again, you can visualize Pythagorean theorem and calculate r as the square root of x squared plus y squared. So it looks like we're going to get r equals the square root of 5. Therefore, sine of alpha defined as y over r is equal to 2 divided by the square root of 5. Now, it's customary in trigonometry to rationalize the denominator. So we can go ahead and do that by multiplying the square root of 5 to the top and the bottom, and we end up with a value of 2 square root of 5 over 5 for sine of alpha. Similarly, cosine of alpha is equal to the x coordinate, -1 over r, which is the square root of 5. Again, we're going to rationalize by multiplying by the square root of 5 over the square root of 5. So we end up with negative square root of 5 over 5 for the value of cosine. Next, we have tangent of alpha. Tangent is defined as y divided by x. Y in this case is 2, x is -1. So when we simplify, we can see that tangent is equal to -2. Moving on to our reciprocal functions, cosecant of alpha, we can think of it in two ways. We can think of it either as r divided by y, or we can think of it as the reciprocal of sine. Now, if I reciprocate 2 square root of 5 divided by 5, I'm going to have to re-rationalize again. So I might as well reciprocate the original expression that we came up with for sine. Or again, notice, since cosecant is r divided by y, we have r square root of 5 divided by y, which is 2, which is clearly the reciprocal of our first expression here. Next, we'll evaluate secant of alpha. Secant is r divided by x. So we have r. When we simplify, we get negative square root of 5. And then finally, we have cotangent of alpha, which is equal to x divided by y. X is -1 and y is 2. So once again, notice the reciprocal relationships between sine and cosecant, secant and cosine, cotangent and tangent. For this angle alpha, we were using the point -1, 2 on its terminal side. But it's interesting to note that any point anywhere along the terminal side of that angle will yield the same 6 trigonometric ratios. So the trigonometric functions are unique for any angle alpha. Therefore, we can use any point on the terminal side to determine the values of those ratios. One thing that you're going to notice about trigonometry is that we're going to study relationships between functions and signs and equations quite a bit. So it will be important to be able to recognize patterns. In example 2, I want us to go through each of our 6 trigonometric ratios and determine their sign, SIGN, in each quadrant. Remembering that sine is y divided by r, the sine of sine is going to be equivalent to the sine of y in that quadrant. So in quadrant 1, Sine is positive because y is positive, and its reciprocal is also positive. In quadrant 2, y is positive, so its reciprocal is also positive. Now, if I look at an angle either in quadrant 3 or quadrant 4, because the sine of y is negative in quadrant 3 and 4, then sine and its reciprocal will also be negative in quadrants 3 and 4. When we consider the sine, SIGN, of cosine, remember cosine is equal to x divided by r, so cosine is determined by the sine of x. Okay, looking in quadrant 1, because x is positive in quadrant 1, cosine is positive in quadrant 1. Similarly, secant, its reciprocal is positive. Now, as we move over into quadrant 2, the sine, SIGN, of x becomes negative. Therefore, both cosine and secant are negative. Moving into quadrant 3, x for any point in quadrant 3 is negative, so cosine and secant are also negative. Back in quadrant 4, x is positive for any point in quadrant 4, so cosine and secant become positive. Then finally, considering the sine, SIGN, of tangent, tangent is equal to y divided by x. So I have to consider the sine of both x and y in each quadrant to determine the sine of tangent. In quadrant 1, both x and y are positive. So a positive divided by a positive is positive. So both tangent and its reciprocal cotangent are positive in quadrant 1. In quadrant 2, x is negative, y is positive. So when we calculate the ratio y divided by x, we're going to get a negative value for tangent, so its reciprocal is also negative. In quadrant 3, x is positive, y is negative, so their ratio, x is negative, y is negative, so their ratio is positive. A negative divided by a negative is a positive. So tangent and its reciprocal cotangent are both positive in quadrant 3. And finally, if you haven't figured out the color coding yet, in quadrant 4, x is positive and y is negative. So the ratio of a positive to a negative number turns out negative. So both tangent and its reciprocal are negative. So to determine the sine, SIGN, of the 6 trigonometric functions in each quadrant, we have to first of all know their ratio definitions. Once we know their ratio definitions and we can determine the sine of x and y in quadrants 1 through 4, then we can make our conclusion. Now, here's an easier way to think about it, or at least a catchy way to think about it. If you remember, all students take calculus. That indicates which functions are positive. In quadrant 1, all functions are positive. In quadrant 2, sine and its reciprocal is positive. In quadrant 3, tangent and its reciprocal is positive. And in quadrant 4, cosine and its reciprocal is positive. So all functions in quadrant 1, sine in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. But again, that can be as simple as thinking about the sine of x and y in each quadrant and knowing those ratio definitions. This is our first perspective of the trigonometric functions, though we will see them appear in different forms throughout the semester.